Databases are everywhere, but you never see them. They're hidden behind the tools and services that you use every day. Ever wondered where Facebook, Tumblr, and Twitter put their data? Yeah, it's all stored in a database. Where do Google store the details of the pages that they index from the internet? Yep, in a database. Where are the contacts in your mobile phone stored? In a database. Databases do most of the work in the information systems that we use every day. So what is a database? Is it just a random collection of stuff all squeezed in together? No, databases are organized. Databases have a structure, and all the data we store in them fits into this structure. Very simple databases are called flat file databases. They store data in columns of fields and rows of records. Let's think about a simple database that Bob uses to store his address book. This database contains the names, addresses, birthdays, and telephone numbers of his friends and family. Bob has met his friend Megan and would like to add her to his address book. He writes down her first name, last name, address, postcode, and date of birth so he can remember to send her a birthday card, and her telephone number. The details that Bob writes down are stored in fields in his address book database. These are the columns in his database file. The information about Megan fills a whole row in his database file. Each row is called a record, and each of the rows holds information about a different person in his address book. Unlike a paper address book, Bob can carry out operations on his stored database. He can search it to find a particular person. Hey, let's look for Megan. If we search the whole address book for Megan, then we might be surprised at what we get back. Bob can make the search more accurate by selecting the field he wants. So he can ask the database to return all the records where first name equals Megan. Or he could ask the database to show everyone with a birthday in December. He can sort the database to show the records in a different order. He can sort them by last name ascending or by last name descending, or use any other field. These columns of fields can store different types of data. Let's have a look at a new and improved version of Bob's address book. This view of the database shows just one record, the one about Megan that we looked at earlier. But Bob has now added a photo of Megan, her age, the time he last called her, and how many times he's called her in the past. The first name, last name, address, postcode, and telephone number fields all store text. Text fields can hold a mixture of letters, numbers, and symbols. The date of birth field has a field type of date, so it stores calendar dates. The last call field is a time type, which means it stores its data in a time format, such as AM or PM, or the 24-hour clock. The photo field stores data of type graphic. This can be any type of image. The age field is a special field. There isn't any data in it. Instead, it contains a special calculation to work out Megan's age based on her date of birth and the date today. This calculation is called a formula, and fields like this have a field type of calculated. The times called field contains data of type number. This can be whole numbers or decimals. So some things to remember. Flat file databases are simple stores of information. These simple databases have fields as columns, records as rows, and are stored in files. Fields can have 6 different types: text, number, date, time, graphics, and calculated. A database can be searched to find specific records, and a database can be sorted into any order based on its fields.